Hello! How can a stretch of dry, lifeless desert become the starting point of a global food supply chain? At first glance, sand and heat seem like the opposite of agriculture. Yet, through engineering, biology, and long-term planning, this harsh landscape is reshaped into a productive orchard. What follows is not just a farming story, but a complete industrial journey, one that begins beneath the desert soil and ends on tables around the world. The transformation begins with land stabilization and infrastructure. Heavy machinery breaks compacted ground, levels the terrain, and defines planting geometry through GPS-guided mapping. Irrigation trenches are excavated, HDPE pipelines installed and pressure tested, and drip systems laid precisely along future tree rows. Filtration units and nutrient injection systems are activated at the pumping station. When water finally moves through the network, the desert shifts from static terrain to a controlled agricultural system. With irrigation secured, biological establishment follows. Soil is amended to improve structure and fertility before grafted nursery trees are transplanted into prepared sites. Each root system is positioned, stabilized, and irrigated immediately to reduce transplant shock. Trunks are protected from solar stress while root development begins underground. The orchard now exists physically, anchored in soil that only recently was barren. As vegetative growth accelerates, structural training defines long-term productivity. Pruning shapes the main framework, trellis systems support branch alignment, and competing shoots are removed to optimize energy allocation. Micronutrients are applied with precision, and irrigation schedules are adjusted through monitored soil data. Gradually, the orchard develops uniform canopy architecture designed for airflow, light penetration, and mechanical efficiency. During dormancy, structural refinement continues. Pruning removes excess wood, improves airflow, and prepares the trees for the next cycle. Organic debris is recycled as mulch, irrigation is reduced, and soil amendments restore nutrient balance. Cover crops protect and enrich the soil surface. Maintenance of pumps, lines, and monitoring systems ensures operational continuity. Even in stillness, preparation continues. With seasonal warming, reproductive development begins. Buds expand, blossoms open, and pollination is managed to ensure consistent fruit set. As petals fall, fertilized flowers transition into small developing plums. This stage marks the shift from vegetative growth to fruit production, setting the quantitative foundation for the harvest. Enlargement requires controlled resource allocation. Excess plums are thinned to improve spacing and final size. Irrigation increases to meet metabolic demand, and nutrient injection enhances sugar accumulation. Skin color deepens from green to reddish-purple as natural wax bloom forms. Brix levels and fruit diameter are measured before harvest clearance is granted. Quality verification precedes removal. Harvest operations are calibrated for speed and preservation. Mechanical shakers detach ripe fruit, while umbrella-style catch systems prevent impact damage. Conveyors separate debris and guide plums into field bins. Rapid transfer from orchard to transport ensures freshness and structural integrity remain intact. At the packing facility, fruit enters water cushioning tanks and multi-stage cleaning systems. Surface residues are removed, moisture eliminated, and optical inspection systems classify fruit by quality and size. Premium plums are weighed, packed into protective containers, labeled, and palletized. The orchard product is now stabilized for cold chain distribution. Pre-cooling reduces internal temperature to preserve freshness. Pallets are verified for thermal compliance before being sealed in refrigerated containers. From controlled warehouse storage to port transport, continuity of temperature management ensures structural and biochemical stability during transit. Upon arrival at processing facilities, refrigerated fruit is unloaded and reassessed. Sampling, lab testing, and AI-assisted scanning confirm integrity and uniformity. Only compliant batches proceed into production channels, maintaining traceability from orchard lot to finished product. Whole plums move through sanitation systems before mechanical pitting separates flesh from core. Sorted plum halves are directed into distinct processing streams, transitioning from fresh fruit to controlled raw material. Plum halves are blanched, arranged, and transferred into tunnel drying systems where moisture is gradually reduced under regulated airflow. Sensors monitor stability until target levels are achieved. Graded and inspected dried plums are packaged as shelf-stable products. Crushing and pressing extract liquid from prepared flesh. Clarification, pasteurization, and de-aeration stabilize the juice before sterile filling and sealing. Bottled juice exits the line as a uniform, ready-to-distribute beverage product. Puree enters vacuum kettles where sugar incorporation and controlled evaporation build viscosity.
irrigations. The central control system stabilizes airflow and temperature as depicted plum halves reach approximately 20.
Monitored bricks levels ensure consistency before hot filling and sealing. The result is a stable, high-density jam product. Clarified juice undergoes multi-effect evaporation to increase solids concentration. Sterilization and aseptic filling prepare concentrate for long-term industrial use. Across all lines, laboratory monitoring verifies chemical composition, microbiological safety, and packaging integrity. Centralized control systems synchronize production data across multiple product streams. Automated cleaning cycles circulate alkaline, acidic, and high-temperature solutions through equipment networks. Pipelines, tanks, and evaporators are restored to hygienic condition, preparing for subsequent production batches. Finished foods are grouped, palletized, wrapped, scanned, and transferred to cold storage. Robotic handling systems optimize load distribution for domestic and international shipment. In retail spaces and home kitchens, the final products are consumed in different forms: fresh, dried, bottled, or preserved. Meanwhile, orchards continue growing and factories continue processing. Each harvest feeds the next production cycle, maintaining continuity between land, industry, and consumer demand. From desert reclamation to finished products on store shelves, this process demonstrates how agriculture and industry operate as a single integrated system. What began as engineered irrigation beneath dry sand now moves through precision harvesting, controlled processing, and global logistics. Behind each product is a chain of measured steps, repeated season after season. The question is no longer whether a desert can produce fruit, but how far that fruit can travel once the system is in motion.